what is the equation that relates potential energy to all of its factors? Well, the formula is potential energy is equal to m times g times h, where m is the mass, and the mass of an object is measured in kilograms. Those are the units. G is our acceleration due to gravity, and its units are meters per second squared. And this is always 9.81 meters per second squared on Earth. Right. H is the height, and that is measured in meters. And PE, it stands for potential energy, and all energy terms are in joules. Okay, so G is a constant. It's always 9.81. And so next we're going to see what effect does mass and height have on potential energy, right? So let's look at mass first. Height. We'll be looking at height first. So on Earth, the acceleration of gravity is a constant. It never changes. Potential energy changes linearly with the height of the object. So an object with double the height has double the potential energy, right? If it has half the height, then it will have half of the potential energy, and so on. So let's have a look at an example here of a box on a staircase here, right? So potential energy is always relative to height and to the ground. So right here, this is our ground, right? And we'll call this 0 meters, right? And we have a box at various points along the staircase. And you should notice that the box has the same mass. So the mass is constant, right? Meaning not changing, right? And our goal here is to determine the potential energy at the various points of the staircase, right? Right? So the only thing that's changing here is the height. The mass is constant, G is constant. So let's figure out what effect does the height have. Well, we're given the value of potential energy at one spot here, right? On the first step. And we're told that is at 10 joules, right? The next step up is twice as high as the first step. So that one is going to be twice the potential energy, right? The third step, now you're 3 times as high, right? So it will be at 30 joules. And the fourth step, now we're 4 times as high, and we're at 40 joules, right? Now going in the reverse direction here, going down this way, now we put it on the ground. Well, what's the energy when you're at ground? Well, the height is 0, so there is no potential energy. Right? So the potential energy is 0. Same as if you're in this case, and the box fell off the top of the staircase and it fell down. At the bottom, what is the potential energy? Well, the potential energy, we're at the bottom, so it is going to be 0 joules, right? So we can say with an increase in height, potential energy also increases, right? And this is a linear increase, right? So if you were to draw a graph and you have potential energy here and we have height, graphing versus height here, it would look something like this. There'll be no curve, it will be a linear relationship, right? This is linear, meaning straight line. Okay. So let's have a look at what effect does mass have. Okay. Now, potential energy also changes linearly with mass. So an object with double the mass has double the potential energy. If you have triple the mass, it's going to have triple the potential energy. All right. So let's look at a similar scenario again and see what effect mass has on potential energy. Okay. So we have our ground here. Once again, our height is equal to 0. And if our height is equal to 0, we have no potential energy. Right? So at ground state, our potential energy is 0. Okay. Now, let's look at the different situations here. We're given a box at 1 kilogram on the first step here, and it has a potential energy of 25 joules. If we add a box on the same step with twice its mass, what is that potential energy of that box going to be? Well, if we doubled the mass, we would also double the potential energy. So if it was at 25 joules, double 25, it'd be 50 joules. So now if we move that 1 kilogram box onto the next step, what happens to the energy? Potential energy, right? We double the height, right? So if it is at 25 joules, and then we double the height, we are now at 50 joules. Right. Now, if we, instead of having the 1 kilogram box, replace a 3 kilogram box, how much energy would that have? Well, that would be triple the mass. So that would be triple the potential energy. So what's 50 times 3? It would be 150 joules. Right? So as the mass increases, the potential energy also increases.